30 cents, right? And we're gonna add 2. So different sign, you subtract, keep the sign of the larger, right? So $2 take away 30 cents. We have $1.70. So we could say h of 3.1 is approximately 1.7. Is it a little bit, does it become a little easier when you think of it as money? Yes? All right. Let's look at question 15. What is this one asking us to find? Oh my God, what are those? You don't remember? That was a whole, like 3 weeks ago, right? With some gummy bears? So we want the limit of the function as we approach negative infinity. So that means we're going forever in which direction?
The left.
To the left, right? So as I go to the left, I need to think about where is the function going? The function, not the derivative. But could I use the derivative to tell me where the function is going? Yes? Alright, so as I go forever to the left, what does the derivative tell me? That the function is what? Increasing, right? So the only way that function can be increasing is if it's coming from where?
Negative infinity.
From the bottom to the what? That's the only way the function can be increasing, right? So that means that as I go that way, the function is actually going where?
Down.
Down. You understand? That's the only way I could describe it as what? Increasing. Yes or no? So this would equal negative infinity. Think about it. Okay? If I draw the curve from over here this way, am I increasing?
Yeah.
Yes. So my derivative is positive. But as I go this way, where is the curve going? To negative infinity. You see it now? Right. Now if I'm going to the right, what's happening to my derivative? It tells me that the function is what? Decreasing. So as I go this way, the curve has to be going what? Down, right? So if the curve is going down, that means it's going to what? Negative infinity.
Yeah, you're getting more out of it.
You see it now?
Yeah.
This one's kind of hard to see because you're going in the opposite direction that we read the graph, right? Okay, but it's actually going. Good questions, good questions. Okay, one more and then we'll go outside and play, okay?
Recess.
I have to take the camera out there so we can record that.
I know.
Nobody misses out.
Mama wants to know if anyone's using the math
Oh, I have no idea. You want to go check with Mr. Munguia?
Okay.
He has the calendar there, okay?
Okay. Thank you.
Yeah. Alright, let's look at this guy right here. What are they giving us?
The graph of
P prime of x. So they're giving us a graph of the what?
Derivative.
Derivative, right? Okay, so this is a list of
Point. Slope.
slopes. So what are the slopes up here on this side?
Positive.
Positive. What are the slopes here? 0. What are the slopes down here? Negative. Which ones did I train you to highlight?
Zero.
The ones at 0, right? So when the derivative equals to 0, those x values are called what?
Wait,
Extremia.
It could be max or mins, but what are they called?
Relative extrema.
They could be relative extrema. They could have horizontal tangents. Actually, they do have horizontal tangents.
There's something numbers.
There's something numbers.
Critical number.
Critical numbers. Thank you. Okay? So if I'm given a derivative graph, maybe it'll help me if I make a what?
Signs.
A sine line from it. Okay? What do you think the questions are going to be? Where is it decreasing? Where is it increasing? Where's the max? Where's the min? Could I get that right away from the sine line?
Yes.
Yeah. So let's make a sine line for P prime. What are my critical values? -3, to figure out the signs. We don't have a table now, right? We don't have a function, but we have a graph. So let's see, on the left side of -3, what kind of values do I have? Positive. So it's increasing the function. Between -3 and 0, what kind of values do I have?
Negative.
Negative. How cool. Between 0 and 3, what kind of values do I have? Negative. This is awesome. We don't have to think. From 3 to infinity, what kind of values do I have?
Positive.
And this sign line is awesome. Science is awesome. I know. 21. Where is the original function decreasing? Can you tell me really quick? -3 to 0, union? 0 to 3. Why? Because what? F prime, F prime, E prime of x is less than 0. Good. Just a minor technicality. Where is it increasing? Negative infinity to? -3, union?
-3.
3 to infinity? Because? P prime of x is greater than 0. Where do I have a maximum?
At 0. Oh.
At 0?
Negative.
No. At what? -3. Follow the curve, right? So at -3 I have a maximum because the derivative changes from positive to negative. Where do I have a minimum? At +3, again the derivative changes from negative to positive. Easy? The last question. Approximate the value of P of 1.8 using the tangent line approximation if P of 2 is equal to -3. So in order to do that, I need to know what?
The equation.
The equation of the tangent line. So I didn't baby you on this question. I didn't ask you for that first and then ask you to do that. I just asked you this question and you're supposed to look at it and know. I need to get my tangent line first and then use it to make that approximation. So let's do it. What are the two things I need again?
Plot and plot.
Very good. My point and my slope. What would be my point? 2, -3. And I need my slope of the tangent line at what number? At 2, because that's my point of tangency. So where would I get that from? From the graph. So I go to the graph, I go to 2, and I'm looking at where I touch the graph, and I touch it at what? -4. That's the slope that's listed, right? My equation should be y plus 3, x minus 2. Beautiful. Good? Alright, so now from there, we can make our approximation, right? So we're going to say y plus 3 is equal to -4 times 1.8 minus 2. Is 1.8 very close to 2? Yeah, so that should be close enough to use the tangent line. Alright. So what would we end up with here? -0.2, right? $2 take away $1.80. And then 20 cents times 4. 80 cents. So y plus 3 is equal to 0.8 minus the 3. So $3 take away 80 cents. $2.20. Which one was greater? The 3, so it's a negative. Do I just leave it like that? No, we say P of 1.8 is approximately -2.2. Recess time?
Begin.
Cool?
Begin.
You got this, guys? Super easy? Alright, so the assignment to this set of notes, I want you to treat it as being part of the review. I'm going to give you both of them right now. I'm gonna give you the assignment that goes with this and the review. Put them like together, because we're so close to the test, I don't wanna count it as an assignment, because I'm not gonna have time for you to give it back to me, grade it, and me give it back to you. Okay? So everything else has already been graded. I'll pass it out tomorrow while you're working on your review, while we're going over it. And you can use it to study over the weekend, okay? Obviously, if you're turning in something late, well then, you won't get it back. Unless I get a chance today to grade it, right? No promises, okay? Sounds good?
Yes.
Alright, so this assignment and the review I'm gonna give you, you work on it together as one big complete review. Then we'll talk about it tomorrow, and if we need to talk about it some more on Tuesday, we will, but we won't use the whole block on Tuesday to go over the review. So make sure that you're ready for questions. I don't wanna give you the test on Tuesday, because you're coming back from a 3-day weekend, and then my grades probably won't be as great as I want them to be. We do not have school on Monday, no. Okay?
Presidential
Who
plate.
are you?
Okay? Every month, I think we have one day off, unless we have other
I like
days.
pens. I like she was running for president.
Sounds good?
They just switch roles.
Yeah,
Like,
Trump.
like
Trump
the,
vice president. Pence,
Cool?
you're president.
Alright, so let me pass,
He's just so chill.
pass
Yeah,
up the
it was like
assignment.
it was just regular conversation.
well, for
Yeah,
him,
This
yeah,
up,
the other
please
guy
make
was
sure
like,
everyone gets.
Kane was like,
This is annoying.
so you're gonna come watch my show?
Your show?
Yeah.
When do you perform?